Alright, we are in section 3.8, slopes of parallel and perpendicular lines. Let's look at the solve it. You and a friend enjoy exercising together. One day you're about to go running when your friend receives a phone call. You decide to start running and tell your friend to catch up after the call. The red line represents you in the blue, and the blue represents your friend. Will your friend catch up? So, if you guys remember, they look parallel. So there's something with slopes, with lines being parallel and perpendicular. Let's look. It's a lesson. Alright. So, checking for parallel lines. Are lines 1 and 2 parallel? Explain. Alright, so if they're parallel, they have the same slope. If it's a negative reciprocal, they are perpendicular. So, are lines 1 and 2 parallel? So I'm going to choose, to look at that, I got to compare their slopes. So for line 1, the slope is going to be 5 minus negative 4 over negative 1 minus 2. It's going to be 9 over negative 3, and the slope's going to be negative 3. For line 2, I'm going to do m1 and 2 equals 3 minus negative 4 over negative 3 minus negative 1. It's going to give me 7 over negative 2. And that's my slope. So since these two slopes do not match, they are not parallel. Alright, so try to got it down here. Alright, so number 2 is asking us to find what is the equation of the line parallel to this, and it goes through point negative 1, 8. So that means that if I have a line about, say this is about y equals 3x minus 5, and I want a line negative 1, 8. I want a line that goes through negative 1, 8 that's also parallel to this line right here. I want these two lines to be parallel. So, if they're parallel, that means they have the same slope. So what's the slope in here? Negative 3. So therefore, and I have my x1, my y1, I'm going to plug it in. I'm going to use point slope form. So therefore, I'm going to have my y minus y1, which is 8, equals negative 3 times x minus negative 1, which is plus 1. And so this is my answer right here. This is the equation of the line that goes through negative 1, 8, and is also parallel to y equals 3x plus minus 5. Alright, so try to got it down here. Alright, problem 3 is very similar to problem 1. I want to know lines L1 and L2 are neither horizontal nor vertical. Are they perpendicular? Explain. Alright, so I know you can see it here, but I'm going to choose 2 points. So for line 1, I'm going to choose negative 4, 2, and 0, 4. So I'm going to get the slope of those. 2 minus negative 4 over negative 4 minus 0, which gives me 6 over negative 4, which gives me negative 3 halves. Alright, line 2. So in order for these to be perpendicular, I need the other one to be 2/3. So it is going to be 3 minus negative 3 over 4 minus negative 5. 6, 9, which gives me 2, and 3. So 2. Alright, so since this is the opposite and a reciprocal, line 1 is in fact parallel to line 2. So yes, they are. Alright, so why don't you try to got it? Alright, so problem 4 asks, what is the equation of the line that is perpendicular to y equals 1/5 x plus 2, but also goes through 15, negative 4? So that means that if this is y equals 1/5 x plus 2, roughly, that means that I want a line that's parallel, goes through 15, negative 4, I want this line to be parallel. So, remember what parallel means. Alright, so let's first identify our slope. Our slope is 1/5. So therefore, my slope is going to be -5. That's going to be negative reciprocal. So, that means I'm going to do, and this is going to be my x1, my y1. So it's going to be y plus 4, because this is minus -4, -5 times x minus 15. And that is our answer. So this is the line that's going to be perpendicular to this line right here. So try to got it down here. And then here's problem 5. So problem 5 asks, the baseball field is on a coordinate grid with a home plate at the origin. The baseball hits the ground along the lines shown. The player at 110-70 runs along a perpendicular path to the path of the baseball. What is the equation of the line on which the player runs? Alright, so first we got to find the slope. So if he starts at the origin, he runs along 110-70. Alright, so let's find the slope of the baseball's path first. It's not easy to just do that. Alright. So I'm going to use points 30, 10, and 60, 20, because those are the most defined points. So I'm going to find the slope first, which is 20 minus 10, 60 minus 30. So m equals 1/3. Alright, so now my next step is I'm going to find the equation of the line which the player runs. That means I have to find the slope of the perpendicular one. So this is the slope of this line right here, but I want the slope of the perpendicular line. So that means my new slope is going to be -3. Take the reciprocal and take the negative of it. So now I want to find the equation of the line. So I'm going to do y minus y1 equals m times x minus x1. But the point I'm using is 110-70. So my x1 and my y1. So y minus 70 is going to equal -3 times x minus 110. And that is the equation of the line. Because the player runs along a path perpendicular to the path of the baseball. He runs at 110-70. That's the perpendicular line that he wants. Alright, so let me try to got it down here.